Hello everybody, let's see how static and dynamic memory allocation of objects work in C++. So to explain the concept of memory allocation, we're going to use a sample class rectangle. So it has two fields, length and width, and then constructors and setters and getters, along with a method called print_info that just prints length and width. So visually, it will be represented as this box with two values, length and width. In the main function, we are going to declare two objects, one statically and one dynamically. So let's first see how to statically allocate a rectangle object. We put the class name rectangle and then object name is R1, and we are assigning length and width values of 1 each. Now let's see how this object R1 is represented in memory at compile time and runtime. There's going to be the object R1. It has two fields, length and width, both assigned as 1 each. Length is 1 and width is 1. At runtime, it'll still be same. R1 and it has length and width of 1 each. So R1 will be represented same whether it's compile time or runtime. Now let's declare another rectangle object but dynamically. Here we write it like this: rectangle pointer R2 equal to new rectangle 2 length and 2 width. So one thing to remember is this R2 is not the rectangle object itself, but it's a pointer to rectangle. So this is how it's represented, rectangle star, because it's not the rectangle itself, it's just a pointer to rectangle. So at compile time, the R2, because it's a pointer variable, is just pointing at some random location. So that's why this is an address. We call it garbage value. So it's just pointing at some random location. At runtime, however, it will still be there with the garbage value. So at runtime, the right side of this statement would execute. This statement would create a rectangle object. And let's say this object was created at memory location 100. And then because of this assignment statement, this address would be assigned to the pointer variable R2. So now, instead of it being a garbage value, it has the address of the rectangle that we created. So 100 is passed on to this pointer variable. It gets stored in the variable R2. So that would mean that now we have the address, so we can go to that rectangle object. So this arrow would represent that this R2 is now pointing at memory location 100, where the actual rectangle is stored. Now let's see how we can call functions on these objects. If an object is declared statically, then we use the dot operator. So like here, R1 dot print_info being the function. And if we allocate an object dynamically, then we use dash and greater than sign, also called an arrow. So R2 arrow print_info. The effect is still the same. It'll still print the same information. So let's compile this program and we'll see this. So for R1 is printing length of 1 and width of 1, and for R2 is printing length of 2 and width of 2. So the output is still same for both of these objects. It's just that the way they are called is based on how they were declared. So if you declare something statically, we use the dot operator, and if we create an object dynamically, then we use the arrow operator. Thanks for watching.